Hello everybody, we're getting ready to do lesson 6.5 SAT Math Level 1 today. Basic Trigonometry is 6.5. You got 58 points here on the tune-up sheet that follows this lecture. You have a whopping 66 points here of note-taking, so get prepared with your notepad. Okay, this section reviews some basic trigonometric facts and relationships that you need to know for the new SAT. The Greek letter theta is sometimes used to represent the unknown measure of an angle. So you'll be using this a lot, theta, this kind of like circle with a line through the center of it. Measuring angles in radians. Degrees are a measure of rotation where 1 degree equals 1/360th of a complete rotation. A radian is a unit of angle measure that expresses the measure of an angle as a real number. 1 radian is the measure of a central angle of a circle that intercepts an arc whose length is the same as a radius of that circle. So what does all that mean? Well, let's see this. So in this situation here, we have a radius equals 12. Here's a radius here. This is another radius. Okay, so S here equals 6 pi. So the central angle theta intercepts an arc that is 6 pi inches in length. So this is an arc here. This is an arc that's 6 pi inches in length in a circle whose radius measures 12 inches. So with a radius of 12 inches and with this angle here, theta, we're going to say that the length of this arc would be 6 pi. The measure of angle theta in radians is 6 pi over 12, which equals, when you simplify, would equal pi over 2 radians. So in actuality, this length would be pi over 2 radians, because it would be the length of this divided by your radius. In general, theta is S over R, or S equals R times theta is another way of putting it, where S represents the length of the arc intercepted by a central angle that measures theta. Radians in a circle with radius R. So here is a lot of terminology here that you need to put in your notebook for sure. Take all this down. Go forward with this. Converting between radians and degrees. Degree measure of arc of a circle is 360 degrees. 2 pi radians equals 360, so R radians equals 180. So, I'm sorry, this is pi radians here. This would be pi. So pi radians would equal 360 divided by 2 would equal 180 degrees. This relationship provides a way of converting between radian and degree measures. To change from degrees to radians, multiply the number of degrees by pi over 180. So let's get into an example of that. Well, so we have 60 degrees. We can convert it into radians by multiplying your degree measure times pi over 180, or pi over 3 radians is what 60 degrees would be. To change from radians to degrees, multiply the number of radians by 180 degrees over pi. So we have 7/12 pi radians. To convert that into degrees, we multiply 7 pi over 12 times 180 over pi. So this cancels with that, and then 12 goes into 180, 15. So 7 times 15 would be 105 degrees, and that would be the degree measure of 7/12 pi radians. So 60 degrees. How many radians would 60 degrees be? Well, to do that, we multiply 2 times 30 degrees equals 2 times pi over 6 radians, which would, when you cancel this, give you pi over 3 radians here. Would be another way of figuring radians from a degree measure. Figuring out radian equivalent, so 150 degrees would be how many radians? 270 degrees would be how many radians? 315 degrees would be how many radians? So as a little assessment here, 5 times 30 would equal 5 times pi over 6. We know that 30 is pi over 6, right? So when we multiply that through, we get 5 pi over 6 radians. And then here, how many 30s have we got here? Because we know that 30 degrees is pi over 6. We know that much. So if we did that, or we can do 3 times 90s. A 90 degree would be a pi over 2 radians. So it'll be 3 pi over 2 radians, so it'll be 270. And then here, which multiple could you use where you know how many radians are in it? 315 will be a 45, so you have 7 45s. 45 degrees would be pi over 4 radians, so it'll be 7 pi over 4 radians here for 315 degrees. Okay, using the table, right triangle trigonometry, basic 3 trigonometric functions. Here's a right triangle here, and then quotient relationships. So for sine A, leg opposite angle A, which would be over here. Sine A would be leg opposite angle A over C over the hypotenuse, which is C. So it'd be A over C. And then cosine A would be leg adjacent to angle A. So this would be a leg adjacent here, which would be B over C. So it would be a B over C. Leg adjacent to A would be B over C. That would be cosine A. Because so it would be sine A over cosine A would equal tan A. This is another situation here where we get into tan, which would be sine A over cosine A. And then tan A would be leg adjacent to A. Leg adjacent to A, which would be leg opposite A over B. So it'd be A over B here, A over B. That would give us a tan, so it'd be opposite over adjacent. So this would be your opposite, this would be your adjacent here. So it'd be A over B would be your tan A. Okay, cofunction relationships within trigonometry. Two angles are complementary if their measures add up to 90 degrees, or pi over 2 radians equals 90 degrees. The sine and cosine functions have equal values when their angles are complementary. For example, sine 50 equals cosine 40 and cosine pi over 3, which equals sine pi over 6. If x is an acute angle measured in degrees, then sine x equals cosine 90 minus x, or equivalently, cosine x equals sine 90 minus x. If x is an acute angle measured in radians, then sine x equals cosine pi over 2 minus x, or equivalently, cosine pi over 2 equals sine pi over 2 minus x. So these are cofunction relationships, sine and cosine. And so when these are both cofunctions of each other, there's different ways of explaining sine x as cosine pi over 2 minus x. And then cosine pi over 2 would equal sine times quantity pi over 2 minus x. Okay, indirect measurement. Trigonometric functions are particularly useful when it is necessary to calculate the measure of a side or an angle of a right triangle that may be difficult, if not impossible, to measure directly So, for example, to determine the distance across the river, as shown, a surveyor marked 2 points on the riverbank, so H and F, 65 meters apart. She also marked 1 point K on the opposite bank such that segment KH is perpendicular to segment HF. So KH is perpendicular to HF here. If angle K equals 54 degrees and X is the width of the river, X would be the width of the river here, which of the following equations could be useful to find X? So we have a choice here of which one of these equations will give us X. So to find that, represent the width of the river KH by X. Because the problem involves the sides opposite and adjacent to the given angle, use the tangent ratio. So we're going to use tangent here. Opposite side HF, HF here from this angle here, and then adjacent, which would be KH to 54 degrees here. This will be opposite, then this will be adjacent. So our tan angle K would equal opposite side over adjacent side. So we know our angle K is 54, and we know this is 65. So we need to solve for X here, which is our KH here. So when we know the two other parts of that equation, we can solve for X. So since this is not one of the answer choices, consider the other acute angle of the right triangle at F, which measures 36 degrees. This would be a 36-degree angle here. So tan F would equal KH over HF. So the tan of angle F would equal KH over HF. So tan 36 would equal X over 65. And then this gives us the right relationship here to determine the length of X here. Angles in standard position, trigonometric functions of angles greater than pi over 2 radians equal 90 degrees, or less than 0 radians, which equals 0 degrees, can be given meaning by placing angles in standard position in the xy plane. An angle is in standard position when its vertex is at the origin in the xy plane, and one of its sides, called the initial side, remains fixed on the x-axis. So to idea of this, the side of an angle that rotates about the origin is called the terminal side of the angle. If the terminal side of an angle rotates in a counterclockwise direction, as shown in this diagram that will be coming up here, like here, if it rotates like this in a counterclockwise, the angle is positive. So whenever you have an angle that's rotated like this, it is positive. When it rotates in the other direction, it would be negative. And this is called your terminal side here. This is the initial side here on the x-axis, where theta is greater than 0 in this situation. If the terminal side of the angle rotates in a clockwise direction, the angle is negative. So when it goes this way, it would be a negative angle, like this here. If it rotates like this, then theta would be negative. Defining trigonometric functions using coordinates. So if point xy is any point on the terminal side of an angle in standard position, and r is the distance of point P from the origin, then trigonometric functions can be defined in terms of x and y and r as shown. So here we have this quadrant 1 here. This is point xy here. This is your terminal side. This is your theta here. This is theta, which would be positive in this situation. And if you're rotating like this, you have a positive theta. And this would be r here. The length of this would be r for r on this angle here. We're going to use this triangle to do trigonometric functions of this angle and lengths of this triangle. If a perpendicular is drawn from point xy to the x-axis, a right triangle is formed in which x, y, and r are related by the Pythagorean equation. So we use the Pythagorean equation here to do our calculations. If point xy is on the terminal side of, so coordinate definition, standard position of angle theta in xy plane. If point xy is on the terminal side of an angle theta, in standard position, we get this situation here. Here's another diagram here. Then sine theta equals y over r. So sine theta would be y over r. This would be opposite over our hypotenuse here for this angle here, theta. And then cosine would be x over r, would be adjacent over the hypotenuse here of r. And then tan theta would be y over x, opposite over adjacent, where x squared plus y squared equals r squared. So we're still using the Pythagorean theorem of our side lengths. Signs of trigonometric functions in the four quadrants. The signs of a trigonometric function of angle theta depend on the signs x and y in particular quadrant in which the terminal side of theta lies. For example, in quadrant 2, x is less than 0 and y is greater than 0. So tan theta would be positive over negative, which would be negative. Okay, so getting to another table here about some trigonometry. Quadrant 1 is the only quadrant in which all of the trig functions are positive at the same time. This is quad 1 right here, quadrant 1. Quadrants in which trigonometric functions are positive. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. 1, 2, 3, 4. So all are positive in quadrant 1. Everything is positive here. Quadrant 2, sine is positive over here. This is your sine. It will be your y values here. And then quadrant 3 is negative over negative. So everything is positive there for tangent. And then for quadrant 4, cosine is positive. Again, cosine would be your x values here. So they're all positive. So that would be positive there. Okay, so if point negative 3, 4, so this would be negative 3, 4, is a point on the terminal side of angle theta. So here's angle theta, and then here's your terminal side here. What is the value of cosine theta? So we need to find the value of cosine theta here. Here are our choices. So since x is negative 3 and y is positive 4, the terminal side of the angle theta lies in quadrant 2. This is quadrant 2 here. The lengths of the sides of the right triangle form a 3, 4, 5 Pythagorean triple. So r equals 5. The length of this is 5 up here to negative 3, 4. So cosine theta equals x over r equals negative 3 over 5. So that would be your solution to this question up here. In the xy plane, O is the center of the circle. Here's O. So this is theta here. And the measure of theta is k pi radians. So k pi radians would be the measure of this angle here, theta. If 0 is less than or equal to theta, and theta is less than or equal to 2 pi, what is the value of k? So In this situation here, since -1, -1, taking this point here, equals xy, and then y over x would equal 1, -1 over -1 would be 1. So triangle AOC, AOC is a 45-45 right triangle, yes? With the measure of AOC, AOC, this angle here, this part of the angle here, would hence theta would be 45 degrees. So this would be a 45-degree angle there. Now with that same situation here, we're going to grid in. Measures 225. So this is 180 plus 45 would be 225. Or equivalently 5/4 pi radians. So this would be 5/4 pi radians, this measure here. Grid in 5/4. So it would be 5 and then over and then 4. That would be your grid in there for that. Angles greater than 2 pi radians. An angle of 410 degrees exceeds one complete rotation by 50 degrees. So its terminal side will lie in quadrant 1 and form an angle of 50 degrees with a positive x-axis. A trigonometric function of an angle greater than 2 pi radians or less than 0 radians can be written as the same function. So if an angle, same function of an angle between 0 and 2 pi radians by subtracting or adding a multiple of 2 pi. So let's see an example of that. Sine 410 degrees equals sine 410 minus 360 equals sine 50, because you're 50 degrees above the positive x-axis. And then cosine 870 would be 870 minus 720 would be cosine 150. And then tan 9 pi over 4 would equal tan 9 pi over 4 minus 2 pi would equal tan pi over 4. And then cosine the negative pi over 3 equals cosine negative pi over 3 plus 2 pi would equal cosine 5 pi over 3. Reducing angles of trigonometric functions. The reference angle denoted by theta prime is the acute angle formed by the terminal side of the angle. That would be your reference angle. Reference angle theta prime in the 4 quadrants here. So this is a theta prime here, which equals theta. This would equal theta here is theta prime, and it goes from your your x-axis there up to the terminal side. Quadrant 2 would be 180 minus theta, so it'd be 180 minus theta. And then quadrant 1 would be theta prime equals theta. And then in quadrant 3, it would be theta minus 180. So this would be your theta minus 180. So this is your theta minus 180 would equal theta prime. And then in this situation, theta prime, this angle would be 360 minus theta. It would be this theta minus 360 minus theta would give you theta prime. Express cosine 135, this is cosine 135, as a function of its reference angle. So this this will be a 45 degree here. We go 135, we go 45 more, and that would be your 1 pi over there, pi. The trigonometric function of any angle theta can be expressed as either plus or minus the same trigonometric function of its reference angle. Locate the reference angle theta, theta prime, and find its measure. So theta prime would equal 180. This is 180 here, minus 135 would be theta prime would be 45. Again, using this as an example here, determine the sign of the cosine function in the quadrant which theta pi is located. Since cosine is negative in quadrant 2, cosine would be it would be a negative x value here, over your hypotenuse, which would be positive. So it would be a negative sign. Cosine 135 equals negative cosine 45 degrees, which would be here. Similarly, because sine is positive in quadrant 2, sine would be positive because that would concern your y values, while tangent is negative. Tangent would be y over x, so that would be negative. So the sine of 135 would be sine 45, and tan 135 would be negative tan 45 in that case. Draw your own diagram and confirm. Sine 310 equals negative sine 50. Cosine 670 equals cosine 670 minus 360 equals cosine 50. So go ahead and draw on your notes, sketch this axis here, and then sine 50, 310 would be over here, be 50 degrees shy of being 360. And since it's sine, we have a y over x scenario here. It'll be a negative y here over the length of your hypotenuse, which would make it a negative sine 50. And then 670 minus 360. So 670 would be that'd be, let's see, 670 would be 360, then 720 would be 50 degrees shy of being 2 complete revolutions. And since it's cosine, it would be positive because it would be the x values, x over r, and x values here are positive, so your r is always positive, so it would be a positive cosine 50 in that case there. Draw your own diagram and confirm. Tan 880, so it'll be tan 880 minus 720 be a negative tan 20. So 880 minus 720, 720 would be 6 complete revolutions. And then you have, another, 180 would be 900. So it'd be over here, it'd be in your quadrant 2. And then since tan is y over x, your y is positive, but your x would be negative. So it'd be a negative tan 20 degrees for tan 880. It would be in your quadrant 2, which tan is negative. And then tan 5 pi over 4 would equal pi over 4. And pi over 4 would be a 45 degree angle here. So it'd be y over x, which are both positive here, so it would be a positive pi over 4 there. And then draw your own diagram and confirm. We have sine negative 140 would equal sine 220 would equal a negative sine 40. So 140 here would be shy of 180 by 40 degrees. So it would be a second quadrant angle here, and it would be sine. So in this situation here, sine 220, wait a minute here, sine negative 140, sine would be y over r, 140, oh, negative, so we're going in a negative direction now. We're not going in a positive direction here. Positive would be this direction, it's a negative 140, so this would be 90, and then another 50 degrees would be here. So it would be a negative sine 140 would be down here. It would be in quadrant number 3. And down here, sine would be negative. So it would be a negative sine 40 degrees for sine negative 140. And then cosine 10 pi over 3 would equal 10 pi over 3 minus 2 pi would be a negative cosine pi over 3. So negative cosine pi over 3 would be a 60-degree angle, and it would be a negative direction here. 10 pi over 3 would be 3, and so it'd be 1. It'd be 1 pi, and then this would be 2 pi here, and then 2 pi, and then this would be a 3 pi here. So it'd be 3 pi, and then 1/3 of a pi down here. So down here, cosine would be negative because it's the x values here would determine whether your cosine is positive or negative. It would be negative, and then negative cosine pi over 3 would be a negative 60-degree angle here. So it would be 60 degrees here. So it'd be 180 plus another 60. So it'd be something like this. Is where your negative cosine pi over 3 would be down here. And that is your 6.5 SAT Math Level 1 lecture for trigonometry. Your 6.5 tune-up lesson will be coming up. And if you need other materials for this course, email me here for that. You need some tutoring, email me, and solution PowerPoints, email me. And we'll get right to the 6.5 tune-up. Thank you very much.